DraftScience video, I think. Yep, I can't sleep, which is weird for me. I usually can sleep really easy. So, anyway, yeah, I just had stuff rolling in my head. And I just can't, get it to stop rolling. Anyway, okay, here's the overview picture thing. So let's just start there. So everything that's happening on this material universe, this big things like us, isn't really happening to us. It's happening to our atoms and the bits that make up the atom. So if there's a concept like gravity, we think it's happening to us, but it's not really happening to us. It's happening to the atoms. It's where the force starts. So when they look at these forces like magnetism or electricity or gravity, and they attempt to say, let's put this all in a package and understand it all, well, the problem they're doing, the mistake being made, is they're thinking the force, the thing, is a force affecting them when it's really a force affecting their atoms. It's an atomic force, not a big thing force. And we just see it as a big thing force because we're a big thing and we're egocentric. We're, whatever the word is that, centric. We're full of ourselves and think, well, if it's affecting me, then it must be me it's affecting. We just can't give the parts credit, sort of, so kind of. Alright, so anyway, so the point is here is that this whole universe is just made out of this stuff going the speed of light. That's the quanta. There's just that. All the rest of it is just a shape that can take, form, a filtered packet of that. So I'm a filtered, humongous pile of these little things going the speed of light. Now, conventional physics, even the old physics and the new physics, both are perceiving this light thing, the photon, as being a thing, a single thing. And they're applying to it properties, wavelength and frequency. I don't think it's without irony, okay, that wavelength and frequency are the same thing. Mathematically, you can't, they're just inverts of each other. It's the same property, the period, that creates both. You'd think that would be sort of a giveaway. But anyway, my point would be, is that it's not the photon. It doesn't have the property. It's, again, the arrangement of them, the filtering of them. They're in a configuration that makes them something we identify as something. Just as this configuration of light is recognizably different than other configurations of these little things moving the speed of light. Alright, so the thing to understand is that light comes in photons. The little bits, the quanta, let's call them quanta. The quanta, okay, can be doing two things. They can be going from point A to point B in a straight line at the speed of light, or they can be going to point A to point B, okay, in a circle, okay? But that's it. Those are its two options. It has no other options. It's either caught in a relationship to each other, two of them, or it's going the speed of light in a direction, straight line. So that's it. Circle or straight line, and nothing else is happening. Kind of amazing. The whole universe is just made out of that simple stuff. Okay, now it's not amazing to you yet because you don't believe that. But, I have to prove it somehow. And that's where it starts to get a little tiny bit complicated. But it's just a little bit complicated. It's not very, very complicated. Is there something about this spinning thing too? Let's say that it too has a property. You know, it can spin this way, or it can spin that way, perhaps. But there's something about it that makes one configuration of spin different than another configuration of spin, which means that if something from the external world comes down on it, it will react differently depending on which way it's spinning. So let's just deal with this simple thing first. Let's just deal with this simple idea that there's two ways I could explain gravitational relationship, right? You could have the Earth and the Moon, and then you can have the sun, okay, and the Earth and the Moon. And you can sort of understand these relationships, right? The Moon goes around the Earth, and the Earth goes around the Sun, because there's this relationship. Okay, they're tied to each other because of this gravitational force. Now, the real explanation of the gravitational force is this idea that these quanta come pushing from all directions, and there ends up being area between them that isn't pushed on, because it's all straight line. It's all line of sight. There is no filling the void, sneaking in here to create pressure. There's no bendy lines for this light stuff. So it's all line of sight. And so when you shadow something, you automatically attract it. And what's happening is, through this phenomenon, when this gravity goes through something, what it's really doing is it's hitting the atoms, and it's interacting. But what it's also doing is it's not staying in it. It doesn't get captured. The energy, the extra energy, there is extra. Extra comes in this side that doesn't get to this side because this side is shadowed by this, right? So this is blocked, this is shadowed, and therefore there's more stuff comes in this side and gets to this side, but it's not energy. It's not trapped, it's not captured. So what it does is it comes in and it goes out. So that's another thing to understand, is when the gravity comes into a body, that it comes out again. And the thing that it comes out in is a different direction. That's all. It just changes direction. And what it does is give this some of its direction. So it gives direction, more straightness to all the stuff in here. So the stuff inside this, if we were to make a big picture of it, if we make a I have to do a lot of these kind of things, little insets, right? So if I made this embiggened, what you would see is that this is really a bunch of stuff going in all kinds of directions. And what I've done, by throwing more gravity in this way than in some other direction, namely the opposite direction if there's a moon over here blocking the gravity, but more specifically what I end up doing is exchanging direction. So the stuff comes in this way, it gets bent this way, and this stuff, this string, has a little more straightness to it, a little more in this direction is given to it. So what it lost here, it gave here. Directionality. It exchanged direction. So something crooked here went straight, and this went crooked. And that's all that got exchanged. Because all these things are moving the speed of light. They can't. You can only have heat or an energy transfer when something's captured, when the gravity when it fills it up, when it adds to these swirly bits, when it adds more movement inside of it. That's when you have more potential for heat. That's when you gain mass, is you have to actually collect these things. Okay. Back to the point I want to get to is, see, that's where you have to make these, you have to keep going bigger and bigger, which is kind of ironic. See, I could use that apple earth atom metaphor a lot. I could say, to make the photon visible, I would have to make the atom as big as the moon. That's the kind of scale problem. This scaling thing. and just, the brain just stalls almost on the very concept that the head of a pin is zillion, insanely dense with these discrete bits, discrete elemental bits, traveling vectors, traveling lines. Every, just the tiniest little speck, that little tiny speck, zillion, whatever, any preposterous number you want to make up, but I mean, just incredible density, that, the amount of stuff that's interacting. So anyway, so there's two ways that you can have this relationship. You can have this idea of something in the center and then the stuff spinning around it, or you could also understand it as being two things. All right, like a dumbbell. So they spin on a center of gravity, but there's nothing in the center. They're gravitationally being pushed into each other the same way as they would be if one was in the center, but they're just rotating on a center. So one came this way, one was going this way, and because of this gravity thing, a tendency to be bombarded, there's clearly more likelihood of being bombarded from here than there is through this one to here into this side. So you can just sort of understand that if these things are blocking impacts, that there's likely to be occasion when this impact is going to be more on this side than this side for both of these elements, and that tendency would tend to do this directional thing, right? So this one comes in this way, it directionally moves this one this way, and this goes out that way. So I mean, you still have to add these angles, and the angles have to be equal, but that's all you're doing. You're exchanging angular directional information. You're not exchanging any energy. Everything's still moving the speed of light, just moving it in a different vector. So this thing's vector is changed, and then this one would have the same likelihood to have a vector change, and they would just be exchanging vector changes, so they end up circling each other, even though they're not. They're just being changed by the fact that they're not receiving what the equal pressure from all sides. They're receiving more pushes in one direction. So there's no real great way to metaphor this. I mean, but there probably is. I probably can come up with that way. It just takes time. But if it was to think about the air as being little ants or something, I used a school of fish in another analogy, but you could use anything. And think of them as having chaotic direction. So they're moving, there's zillions of them, and they're all moving in no particular direction. They're all moving in straight lines. There's just as many hitting you this way as they're hitting you this way, as they're hitting you from the up and hitting you from down. Okay, so that's the idea. And if you were to think of it that way, you could kind of understand that if something stops some ants over here from hitting you, that the ones over here would have more impact, and they would keep pushing you this way over time. Right? Right. So that's what's happening. So it's just a change in directional information at its core. At the level of the universe, the whole giant universe, at the quantum, the level of the quantum fog, if you were to call it a fog, there's always the same amount of energy. There's no change in the amount of energy in the universe from the universe's perspective. I mean, it just changes shape. It just morphs through its, like a storm going across Jupiter. You don't think of the atmosphere of Jupiter getting stronger or weaker, stronger or weaker. No, it's always the same amount of energy. It's just swirling in little different ways. It's behaving differently. It's manifesting the energy differently, but it's the same energy. I don't know if that's a great analogy or not. Alright, so that's just an important, I think, a feature to understand, is that there's these two ways for gravity, as we understand it, to be manifested. And that we're talking about gravity now on this quantum level, where we're talking about these entities, this mass of quanta, bunch of stuff moving in straight lines, and somehow it gets forced into relationship to each other. So, unanswered yet would be why it all doesn't turn into something caught up next to each other, the relationship. How gravity doesn't, in any real way that we can understand, interact with each other. But that's because it's sort of a secret interaction. We could say it is interacting all the time. All the little bits are hitting each other. So we think of them as ants. Some of the ants are having just such a hard time. Say if they were going from point A to point B, they just keep getting hit by stuff, and with every impact they get knocked in a different direction. And so, they have no momentum, so they can just, they can't move from point A to point B in anything but a chaotic manner. Like, they'll get there eventually, because they'll get everywhere eventually. One could argue they'll just do this stuff all over the place. But the bottom line is there'll always be equal pressure. So for everyone doing this, there's another ant who was intending to go, let's say he was going that way, and he ended up going this way. So for every ant that can't get this way because he gets distracted or pushed by the gravity chaos, there's one who's doing exactly the opposite. He's trying to go this way, and he's getting pushed this way. So it all evens out in the end. So that could be the explanation for that. Is that they are interacting with each other. The pool ballers are hitting each other. It's just that they're exchanging irrelevant directional information. And that overall, it's exactly the same amount of chaos. You can't increase the chaos because it's the same amount of movement all the time. There's the same amount of discrete bits. Okay, that's probably a good way to say it. What decreases the chaos in a sense would be when you end up with this filtered thing. When you end up with these arrangements of these entities where they do some sort of pattern, maybe you could just say a triangle or a square or some kind of pattern that ends up consolidating them. And now they become essentially a new entity through that consolidation. So you could argue that, let's say, I'd say I still want you to understand how this does the unification thing. There's a thing to understand. Say, okay, you got these little quanta banging into each other. They're creating this pressure gradient. So there's megazillions of them. And for any place in space, let's just say space without the consolidates in it, but theoretically, there is a bunch of density in the empty space. Okay, the bunch of these bits moving through the empty space. So I'm just saying you have to understand that part. And for every little point in space, there's a pressure coming from all directions on that space. There is no space that we know of, in at least in the space of the material universe, where there is no pressure. There's some kind of pressure. Whether it's even or not, that's another issue. As you go to the outside of the universe, the pressure may well get uneven. Gravity may be uneven. There may be more of it in that way. Okay, meaning that's why stuff is accelerating at the end of the universe away from us, is because there's less gravity on one side of it than there is on the other side. It's leaving the pressure gradient. Yeah, well, so I don't really want to get into that, but I think you could understand that when something explodes, it does this kind of bullseye thing where pressure builds up. You have these waves of pressure, and that's sort of what the Big Bang did, is create these waves of pressure. And so we're like in the strong pressure part of the universe, and it takes a while to get into a completely uneven pressure gradient. So this one's a very even, like all the pressure is even from all sides. This one's a little more going this way, and this one's a lot more going in one direction. You have to get that sort of sense that that's sort of what happens in explosions. I'm not saying there was a Big Bang, I'm just saying, I mean, it would fit in the sense that we sort of know from how things explode. But see, things explode in mediums, and that, in what you would think of as a pure explosion, like the tip of this pen just explodes in a pure vacuum. Theoretically, there'd be no pressure gradient because everything should have a vector it can get away traveling on, and nothing should ever hit each other. All the elements of the explosive should be free to escape. But I think what happens is this stuff on the outside blows up unevenly, and so it tears pieces off, and those spin, and they end up being reflectors. So I think it gets, why don't I get into that? That's not even necessary. So anyway, back to what I'm saying is happening. So understand that what I'm saying is one element of this thing is these gravitons. So one part of the quanta, the things moving the speed of light, is what makes up gravity, and they're the nothing ants. Okay, they're just common ants, let's call them. They're light without frequency. Okay, so that means they're not in pairs. See, and that's the frequency thing, so we're back to that dumbbell. So remember the dumbbell drawing, right? So they got the two gravitons, and they're associated to each other because one was going one way, one was going the other way, and gravity is pushing them together. And so each one is getting deflected into the other over time, and so they're associated. Now you could sort of understand that might be something like an electron. An electron might have no nucleus, it just might be a bunch of these associated opposite planets. So it would be like there's no sun, and there's just Earth and an Earth, and they rotate without the sun. I think that's perfectly mathematically possible that you could have that scenario where you have no necessity of having a gravity, a mass, at the center of gravity, and just the gravity between the two bodies would be enough to keep them in association with each other. I think you see this in like big picture stuff, like when two galaxies collide. Two galaxies sort of do this. The black holes at the center of the galaxies do this sort of dance, where the two of them end up blending into one. So galaxies essentially merge. They don't do anything else. They pretty much always just merge. I guess they could fly through each other, but I just mean if they consolidate, they merge, which means that you end up with one black hole and all that kind of stuff. But anyway, that's a whole nother... Don't need to get that complicated. My argument is it is this association between these gravitons that creates what you might see as or understand to be the origin of the photon. That now what's being released, if you release one of these, the other one automatically is released. Because there's no mass holding them together. These two masses are holding them together. So now when you knock one free, you automatically knock the other one free. And that's creating that's what's creating what we understand a photon to really be, which is a frequency of graviton, or a frequency of quanta. So it's quanta with a frequency. So gravity, the graviton, is the little ant that has no frequency. It's coming at all kinds of irregular intervals. You just can't see it. Now, it might randomly look like a little flash of light every now and then, like a photon. It might look like an X-ray. It might look like a lot of things randomly as they come into an atom. So an atom might perceive it as an X-ray, react to it as an X-ray, but it's just gravitons that just happen to hit at the right frequency. But these things are specific. These dumbbell associated gravitons are something inside the structure. They're something that perhaps is only created inside either a proton or a neutron and just captured by the electron, or maybe they're something created by electrons. It seems likely, it seems probable, that it's something happening in the nucleus to me. Something is happening in it's a nuclear event, but it doesn't really matter. What doesn't even matter right now. So anyway, what I want to do to finish up here is to get back to you understanding. So far we have, we have the single quanta is gravity. The paired quanta can be anything in the electromagnetic spectrum, so anything with a frequency, from a radio wave to a cosmic ray, whatever. So it just has to do with how close they are together or how far apart they are for an interval of time. So obviously if you have 1 second of exposure to X-rays, you'll have 10 times more bombardments. Like if they were baseballs, 10 baseballs hit you. If they're radio waves, 1 baseball hit you. That's the higher energy, is in the fact that you're getting hit more times. There's more of them that hit you in a given amount of time, which makes them more energetic. But the photons themselves, the quanta, aren't more energetic. There's just more of them. Lower frequency, well, higher frequency, higher in that smaller distance between them. That is kind of a non-intuitive. I know that the frequency number goes up, and what that really is saying is the number of them, per moment of time, and the wavelength is inverted. Like I said, it really is not the best way to describe this. I mean, they shouldn't have done that. They shouldn't have. They should have stuck with the word frequency and a period and understood that that's what's really happening, that it has to do with how many of them are going to hit you. But the fact that they turned it into something that's a quality of the thing itself is where it all went wrong. So anyway, now when you get to magnetism and the electricity, what that is that has something to do with the character of this. Like I said, that might have to do with this rotational direction, clockwise or counterclockwise. But regardless of what it is, a shape dynamic of some kind. Now we know that shape dynamic exists because there's this polarized light, meaning the light is this way or it's this way in terms of a shape. It goes through the bars this way. It doesn't go through the bars this way, if there's bars this way. So there's a shape to it. And that polarization is what creates the capacity for there to be for this to be filtered, for there to be a different impact, a different intensity of impact or reaction depending on which way it comes at you. So what magnetism and electricity are manifestations of gravity in this polarized form. So they're highly polarized. So that just means that the gravity has a character, a shape, that's either up or horizontal. And depending on what you are, I mean, if you're a proton inside the nucleus, and one of these upright fellows hits you, it will push you more. It'll have more impact on you. And if one of these hits you, it'll have no impact. So you'll have 100% impact from these and 0 impact from these. And let's say the original gravity is just a mixture of those. So if something can filter which ones are hitting you, by filtering them, they can intensify the effect of what you're getting hit by. So if it can convert a this into a this, it can double the effect of gravity on you, or triple, or it really just doesn't matter, because you can, as you can change shape, you can also change sensitivity. So it really doesn't matter which way I go with that. But that's what magnetism is. Magnetism is material atoms that are merely creating. When the gravity goes in, it's coming out polarized. And that polarization creates an opposite sensitivity in something made exactly the same material, or the similar, or a magnetic material, a material capable of filtering for magnetic polarization. So that's essentially what you would call a compass, is that it's filtering for magnetic polarization. It's sensitive to it because of the structure. And so it's just gravity filtered. And it's that gravity, likely the gravity that comes out the side, so to speak. It's the doing this directional thing, but from all directions all the time. And again, it's just the same kind of shadowing effect. So when two magnetic materials capable of filtering for polarization are put in proximity to each other, they do the same thing gravity does, which is they block from one side and create that shadowing effect that pulls things together. And when you convert them to make them opposite, to create, well, so you have the attraction and then you have the opposite effect, that sense of repulsion. So when you turn the magnets opposite, they feel like there's more pressure inside. Well, they feel that way because the one side is producing exactly, it's changing all of these, it's polarizing all of the stuff that comes in this direction, which is exactly the thing on the other side, the magnet on the other side, the opposite, the pole, that's the same pole, is exactly sensitive to. And it's doing exactly the same thing. It's producing exactly the same sort of filter. It has the same filter. The north side and the north side of the magnet would both have the same filter. So they're filtering exactly the same thing and forcing to the other party exactly the thing they're sensitive to. I explained this better in an earlier video, but so that's what's creating the illusion. Well, it's not an illusion. The fact of this extra pressure is that the gravitons going in have been polarized to exactly the polarization that the other material is the most sensitive to, and the external gravity still has a bunch of the stuff that goes right through it. So it's invisible to one kind and completely opaque to the other kind, and depending on what one filters, exactly that effect will happen. So either you will feel no gravity from the external because you're only feeling half of it, because you're only being affected by half the polarization, and you're getting twice as much coming from the other direction because the other thing has already filtered it for this extra, the thing you're sensitive to. Yeah, I think that's enough to tie it together anyway. So the thing I have to work, the place where I'm seeing problem here, it's just that this idea, this shape question is interesting. What's the nature of the shape? And because clearly I think the shape has something to do with this scenario of the dumbbell kind of effect. The effect where there is no center of gravity and two things are wobbling on each other. The dumbbell effect. And that somehow that, considering rotation, might be how it's manifested. But again, see, this is the catch is that when light's traveling, light is this released. So what's happening is as these things are spinning, this one comes out, and then this one comes out exactly at the same point, and so they maintain this distance here, directionality wise. And so I have to explain the cause of that also. Obviously it would be a mathematical formula that as the gravity, as these two things were separated, you know, like say, let's say there were these, you know, I wish I had all this, I mean I wish I had graphics I could animate, you know, with really simply, but let's say these two things are spinning around each other. And then let's say I start to release this one, so it just starts going off in this direction. Now this line and this line, this one's going to be a longer line, so the gravity gets less, you know, as they get further and further apart. And so this one comes out a little bit further in its circle. So you can sort of see if the original circle was, let's say the original circle is this. And as this one breaks off, this one starts widening out too. But there must be something, you know, mathematically, where it tends to do this thing, you know, where the two will end up eventually, okay, on an equal vector, and they'll just be, one will be behind the other by a specific amount of distance. So it'll be like this one's here when this one's here, and so this will end up being their final frequency. Yeah, I think you can sort of, well anyway, so I think there's obviously there's a mathematical formula for how this spreading, the weakening of the gravity would affect the curvature and how wide an orbit it would take. Yeah. But I have no idea what that math would be, but I'm just saying that it seems pretty obvious that there would probably be some kind of math that could explain that. Some sort of math formula. So anyway, this is probably enough. Yeah, I just wanted to get, you know, it really is kind of important just to understand that something like gravity, like I said, we think of it as affecting matter or affecting us, and it's really just affecting these little bits inside our atoms. It's an atomic force. Gravity is an atomic force. It's keeping atoms together, forcing the little bits together, and we're just a way external phenomenon to that. The real meaning of gravity is on atomic nucleuses and stuff. That's where it really does its work. It doesn't really do any work in this big world. It does all the work in the little world. Every single solitary atom, it's affecting them right now. Every single one of them. Yeah, that's probably the big takeaway point. Anyway, probably enough. I'm a little more tired, so maybe I can sleep. So anyway, yeah, so more to come. Yeah, so yeah, I didn't do the polarization, but anyway, the electricity. See, the polarization would be like from here to here would be magnetism, and from here to down here would be electricity. But that's, you know, there's your unification thing. Yeah, all done. Just gravity polarized. Just gravity polarized. I shouldn't have to say more. That sort of sounds good. It sounds pretty, yeah, that makes sense. And photons, energy, is just gravitons with a frequency. There you go. All done. So anyway, till next time. And such.